Hi everyone, my name is Owen Sharp. I'm a software specialist for Dietz. I support our Autodesk software and our users. We are going to be creating a corridor for this project, which is for local drainage and roadway improvements. We will be using the corridor to help locate the drainage structure locations, as well as create cross sections with annotations and earthwork calcs. Let's jump in and see what we can do. Now we are creating our corridor drawing. We do this by starting a new drawing from a design template. Once it is created, we will data shortcut in our existing surface and our roadway alignments. Also, we will cross-reference in our existing topographic line work. All were created by our survey team. Now we will cross-reference in our proposed 2D line work, which was created by our design team to be used for reference while creating the corridor. We're using a working corridor on this project. We have a super elevation assigned to the center line. We have a sub-assembly that's reading the super elevations and just building a working surface so we can take our offset alignments that we just created and create a surface profile from the working corridor so we can use that to control the edge of pavement elevations as long as the widths with the offset alignments. We will also use the offset alignments for our intersections, for our connected alignments. They will tie the profiles on the side streets and the main lines together. Once we get those created, then we can look at the profile along our curb returns to verify that we have no flat spots and that we meet ADA slopes within the crosswalks. Here we're drawing polylines for our custom sub-assemblies that we created with Sub-Assembly Composer. We set the targets for the custom sub-assembly once the lines are created. Once all the targets are set, then our corridor will know where to place driveways, where to drop off curb for intersections, and where the existing sidewalk is so we can tie in at the face of the walk. We like to create a single sample line in the corridor and a cross-section view so we can drag it around and see if we have any problems with our design in difficult areas. Our connected alignments then are used to build our intersection corridors. Now that we are finishing up our corridors, we have a wealth of information at our fingertips. We can get quantities, we can build contours, we can do a lot of things with the corridors. Jumping ahead, here is the final corridor with the pipe network in it. We're going to check with a water drop. We're going to verify that our inlets are placed where they should be. So we'll take a quick water drop here, drop it on the surface, and they should end up at our inlets. And as you can see here, the water is going to our inlets. This one it's running past, which is catching some and going on down and hitting additional inlets. The last thing to look at is our cross sections. Here's our cross sections labeled with cut fill volumes, driveways, slopes. This is what we use Simple 3D for. I hope this was educational. Thanks.
Hey everyone, I'm Alex Ostroff and I do road and bridge design for Dietz. We do work all over the Midwest and have been providing quality engineering services for over 70 years now. Let me show you how the skills you're working on today can help you lead projects in the future. Come check it out. Hey, you beat me here. All right, let's get started. In this video, we are going to demonstrate how a project can come to life using Open Roads Designer software. So for this project, we're going to lay out the horizontal geometrics of a roundabout, apply a profile, and build a 3D model for use in construction. What you see on your screen is survey data that was gathered at the start of this project and brought into our design file. The data is geo-referenced to the exact location of the project. You can see this by utilizing some of the mapping tools provided by ORD software. Like any initial design, there are going to be changes made throughout the life of the project. Roundabouts are especially iterative, which is why dynamic features that Open Roads technology provides is so important. Let me show you some of the tools and features we can use to start laying out the ICD. I'll be using civil geometry to place the inner diameter. Then I will tie in each approach to the roundabout and dynamically make changes as I progress through to ensure that all the parameters are being met. But to respect everyone's time, how about we speed things up a little bit?
There, that's looking pretty good. Alright, so now that we have the draft geometrics in place, it's time to run through some performance calcs and make sure that this roundabout passes our standards. This is where Open Roads technology really excels. So as we go through different design iterations, our initial layout will dynamically change with it. This makes that review process more efficient and those submittal days a lot less daunting. So let's make a few changes. Let's say we have some issues with trucks overtracking and need to change the entry width along with the truck apron. Well, in a few clicks, I can edit my design, widen out my approach on the east leg, and come in here and increase my truck apron, let's say by 3 feet. And my design will automatically update. So let's say we need to put some more curvature in for an approach in order to reduce that entry speed. Not a big deal. We can go ahead and click on the handle on some of these approaches, and we can reduce the radius on these curves how we see fit. Alright, so let's say that's looking really good. I think it is. Next up, we would apply some profiles to this geometry so we can add dimension to our design. So how about we start with the ICD, and this will provide some target for our approach profiles. Alright, now that we got all of our line work profiled, let's take a look into our 3D view and see how our brake lines match up. Okay, that's pretty good. It's a skeleton of a roundabout. Still missing a few things before this project can be completed. So the next task that we're looking at doing is creating a template and extruding that template over our profiled lines. That way we can finish this project up and get it to the contractor for build. Let's get it done. Alright, now that's looking a lot better. Now that the model is built, we can use it to pull things like earthwork reports, get our quantities, create our production sheets, and so much more. Once we know how much the project costs, we can let the client know to make sure that they get an honest bid from the contractor. And then we can get this thing built. But until then, we're gonna have to play the waiting game. Whoa, I just got an email from the client. It looks like the roundabout construction's going really well. That was fast. Let's check out some of the photos he sent over. It's pretty cool seeing things go from a couple lines on your computer right to a real-life application. It's even better when you get to experience and witness how it impacts the community around you. If you're interested in becoming a team member, we're always looking for skilled engineers and technicians who know their way around drafting software. Everything you're currently learning can be taken with you and applied to projects around the country. These are just a few of the things we do here at Clark Dietz. Engineering quality of life.